The excess reagent. So, as you saw in the previous video, we have identified O2 as the limiting reactant. And by default, what that means is that the other reactant, CH4, in this particular reaction, has to be the excess reagent or the excess reactant. What that means, in simple words, is that by the time the reaction ceases to take place because you have run out of O2, the limiting reactant, you will have some leftover amount of CH4 that will be present in excess. Basically, once the reaction is over, you will not only have your products form and with amounts pertaining to the stoichiometry associated with O2, but you will have some leftover amount of CH4 still present in the same reaction flask where you carried out the reaction. So we're going to find out how much of the CH4 molecule we actually have left over once the reaction ceases to take place, once the reaction is over. All right, now, one thing that needs to be pointed out right now, because sometimes people make this mistake, and I can see why. It's very tempting. You say that O2 is a limiting reactant, so you might say, well, we already did the stoichiometry right here involving the excess reactant, so this has to be the value. Except that when asked about the excess reagent, technically what you're being asked about is how much amount of the excess reagent remains in solution. And unfortunately, CO2 is not the excess reagent. CO2 is the product. So this equation right here is completely meaningless. And not only that, even though it's giving you an amount for CO2, it's not even the true amount of CO2 because this is not the limiting reactant or deriving from the limiting reactant. This derives from the excess reagent. So this is completely meaningless. So what that means is that you have to start from scratch. And specifically, you're going to start with the limiting reagent. So now that we know that the limiting reagent is O2, any stoichiometry that's to happen in this equation has to start with O2, the limiting reagent. So that's what we're going to do. We're going to start with the 30 grams of O2, once again the limiting reagent, and we're going to switch over to the excess reagent in order to find out what amount of excess reagent actually got used in the course of the reaction. In other words, how much amount of excess reagent is no longer there. So the 30 grams of O2 get changed to moles of O2 using the molar mass of O2, as we did before. The grams cancel out. Now that we're in moles, we will switch over from the limiting reagent to the excess reagent. And for every 2 moles of O2, we only consume 1 mole of CH4. So that becomes the mole fraction that we have right here. And since we have O2 on the bottom, to cancel out the moles of O2 on top, the number 2 placeholder has to be down there. Alright, so canceling out the moles of O2, this now leads us to the moles of CH4. Notice that the amount of CH4 that we have is in grams, so that tells us that stopping at moles of CH4 is not going to be very helpful. You actually want to carry over the conversion from moles of CH4 to mass of CH4 using the molar mass of CH4. Notice that moles of CH4 on top, moles of CH4 on the bottom to cancel out. You now have grams of CH4 as the only unit left over. So divide 30 by 31.98, press enter. Divided by 2, press enter. Multiply by 16.13 grams, press enter, and you should end up with a mass for CH4. Alright, now, this in and of itself is not the answer. What this represents, the value that you're getting out of the stoichiometry, is the actual mass of CH4 that got used up, the amount of CH4 that is no longer there. So to find out the actual value that remains in excess in the reaction flask still, what you have to do is subtract the mass of CH4 that you got from the stoichiometry from the original mass of CH4 that you started with. Alright, so if you subtract 10 with 7.57, you will find out the overall mass of CH4, which we call the excess leftover amount. This is what remains in solution. What you get from the stoichiometry is the amount that you used up in the course of the reaction. So be careful with that. It's a little bit confusing, but you have to keep in mind that the stoichiometry is telling you, as long as you start with the limiting reactant, the stoichiometry is always telling you the amount that you have to use up on the reactant side to carry the reaction over, or the amount of product that you're getting max, right? In this case, we're looking at a reactant, so this is the amount of reactant that has to be used up. Okay, now we'll continue with the process in the next video.